Digital integrated circuits. All of the logic functions that we have enumerated are available in the integrated circuit, IC, form. Modem digital systems utilize integrated circuits in their design. A monolithic IC is an electronic circuit that is constructed entirely on a single piece of semiconductor material, usually silicon, called substrate, which is commonly referred to as a ICs. Have the advantages of low cost, low power, smaller size, and high reliability over discrete circuitry, except in very specialized applications where a circuit must be custom-made to meet the unique requirements. ICs are principally used to perform low-power circuit operations such as information processing. ICs cannot handle very large voltages or currents, as the heat generated in such tiny devices would cause the temperature to rise beyond acceptable limits, resulting in burning out of ICs. ICs cannot easily implement certain electrical devices such as precision resistors, inductors, transformers, and large capacitors. ICs may be classified as analog, linear, and digital. Digital ICs are complete functioning blocks as no additional components are required for their operation. The output may be obtained by applying the input. The output is a logic level 0 or L. For analog ICs, external components are required. Digital ICs are a collection of resistors, diodes, and transistors fabricated on a single chip. The chip is enclosed in a protective plastic or ceramic package from which pins extend for connecting ICs to other devices. There are two main of packages, dual inline package, DIP, and the flat package. Levels of integration. Digital ICs are often categorized according to their circuit complexity as measured by the number of equivalent logic gates on the substrate. There are currently 5 standard levels of complexity. Small-scale integration, SSI. Any least complex digital ICs with less than 12 gate circuits on a single chip. Logic gates and flip-flops belong to this category. Medium-scale integration, MSI. With 12 to 99 gate circuits on a single chip, the WRE complex logic circuits such as encoders, decoders, counters, registers, multiplexers, arithmetic circuits, etc. belong to this category. Large-scale integration, LSI. With 100 to 9,999 gate circuits on a single chip. Small memories and small microprocessors fall in this category. Very large-scale integration, VLSI. ICs with complexities ranging from to 99,999 gate circuits per chip fall in this category. Large memories and large microprocessor systems, etc. come in this category. Ultra-large scale integration, ULSI. With complexities of over 100.000 gate circuits chip, very large memories and microprocessor systems and single-chip computers come in this category. Digital ICs can also be categorized according to the principal type of the electronic component used in their circuitry. They are A. Bernler ICs, which use BJTs. B. Unipolar ICs, which use MOSFETs. Several integrated circuit fabrication technologies are used to produce digital ICs. Presently, digital ICs are fabricated using TTL, ECIIIL MOS and CMOS technologies. Each differs from the other in the type of circuitry used to provide the desired logic operation. While TTL, ECL, and IL use bipolar transistors as their main circuit elements, MOS and CMOS use MOSFETs as their main circuit elements. These technologies are also called logic families. Several subfamilies of these main logic families are also available. Microprocessors. A microprocessor is a LSI/VLSI device that can be programmed to perform arithmetic and logic operations and other functions in a prescribed sequence for the movement and processing of data. Microprocessors are available in word lengths of 4, 8, 16, 32, and 64 bits. Presently, 128-bit microprocessors are being used in some prototype computers. The 4-bit processors are virtually obsolete. Because of their small size, low cost, and low power consumption, Microprocessors have revolutionized the digital computer system technology. The microprocessor is used as the central processing unit in microcomputer systems. The speed of the microprocessor determines the maximum speed of a microcomputer. The arrangement of circuits within the microprocessor, called its architecture, permits the system to respond correctly to each of the many different instructions. In addition to arithmetic and logic operations, the microprocessor controls the flow of signals into and out of the computer, routing each to its proper destination in the required sequence to accomplish a specific task. The interconnections or paths along which signals now are called buses. Digital computers. The digital computer is a system of hardware that performs arithmetic operations, manipulates data, usually in binary form, and makes decisions. Even though human beings can do most of the things which a computer can do, the computer does the things with much greater speed and accuracy. The computer, however, has to be given a complete set of instructions that tell it exactly what to do at each step of its operation. This set of instructions is called a program. Programs are placed in the computer's memory unit in binary coded form with each instruction having a unique code. The computer takes these instruction codes from memory one at a time and the operation called for by the code. Major parts of a computer. There are several of computer systems, but each can be broken down into the same functional units. Each unit performs specific functions, and all the units function together to carry out the instructions given in the program. Figure shows the 5 major functional units of the digital computer and their interconnections. The solid lines with arrows represent the flow of information. The dashed lines with arrows represent the now of timing and control signals. The major functions of each unit are described below. Input unit. Through this unit, a complete set of instructions and data is fed into the memory unit to be stored there until needed. The information typically enters the input unit by means of a magnetic tape, or a keyboard. Memory unit. In addition to the instructions and data received from the input unit, the memory stores the results of arithmetic and logic operations received from the arithmetic and logic unit. It also supplies information to the output unit. Control unit. This unit takes instructions from the memory unit one at a time and interprets them. It then sends the appropriate signals to all the other units to cause the specific instruction to be executed. Arithmetic and logic unit. All arithmetic calculations and logical decisions are performed in this unit. It then sends the results to the memory unit to be stored there. Output unit. Takes data from the memory unit and prints out, displays or otherwise presents information to the operator. Types of computers. The number of computer types depends on the criteria used to classify them. Computers differ in their physical size, operating speed, memory capacity, and processing capability as well as in respect of other characteristics. The most common way to classify computers is by their physical size, which usually but not always is indicative of their relative capabilities. The 3 basic classifications are microcomputer, mini-computer, and mainframe. The microcomputer is the smallest type of computer. It generally consists of several IC chips including a microprocessor chip, memory chips, and input-output interface chips along with input-output devices such as a keyboard and video display. Microcomputers resulted from the tremendous advances in IC fabrication technology that has made it possible to pack more and more circuitry into a small space. Figure shows a block diagram of the microcomputer system. Many computers are larger than microcomputers and are widely used in industrial control systems, research laboratories, etc. They are generally faster and possess more processing capabilities than microcomputers. Mainframes are the largest computers. These maxi computers include complete systems of peripheral equipment such as magnetic tape units, magnetic disk units, eared punchers and readers, now obsolete, keyboards, printers and many more. Applications of mainframes range from computation-oriented science and engineering problem-solving to data-oriented business applications, where emphasis is on monitoring and updating of large quantities of data and information. Hope you enjoyed and gained out of our discussion. Thank you.